So waves question, block 3. Figure 8.1 shows a parallel wavefronts of a light waves in ice, and the wavefronts are incident on a boundary with air. So it is striking ice to air bound. The next part, the speed of a light in air is 3 exponent 8. The refractive index is 1.3. On a figure, draw a wavefront that passes into air. Draw an arrow to show the direction of a wave travel and label the angle of incidence and angle of refraction. And calculate the speed of a light. First thing, as you can see, when a light travels from ice to air, what happened to the speed of light? Increase or decrease? It increases. So we have to draw the wavefronts. Like if I draw the wavefront, same, it means it has the same speed. If the speed decreases, then it should lag behind. But the speed of a light is increasing, so it should move ahead. So these are the refracted wavefronts because the speed of a light has increased. Then what about the direction of the wave? We have to draw the wavefront that passes into air, then draw an arrow to show the direction of the refracted wave, and then label the angle of incidence and angle of refraction. So after drawing the refracted ray, we have to label the angle of the direction of the refracted. How we can draw? Direction of a refracted is always perpendicular to the wavefronts. These are the wavefront. I can take any one of them. If this is a wavefront, so the direction will be 90 degrees. I can take this, or I can take this one, or I can take this one. Any one of them I can take. But the direction of the wave is always perpendicular to direction of the wavefront. So if this was an incident, if we can continue this, this was the incidence, then the refracted, this direction, the red arrow should always be perpendicular or 90 degree to the wavefront. Like this is a wavefront, so this red arrow shows a refracted. So this one is a refracted one. And this one is an incident. We draw a normal. The normal should always be perpendicular or 90 degree to the surface. And we have to label the angle of incidence and angle of refraction. So this will be the angle of the incidence and this will be the angle of refraction. Because I mentioned all the wavefronts to be on the wave direction. Not necessary, not really. You can take any one of them. You can take all of them. It's not necessary that you draw or show all, because if you see the marking scheme point, wavefronts in air, they should be parallel to each other. They should make a large angle. At least one of the wavefront meets an ice, like that is shown. Arrows right angle to the wavefront pointing away from the boundary. That's it. Like, and we measure this angle. So it's not like when we draw them, it's not like we should draw a line which is perpendicular to all of the line should be perpendicular to all, but it should not cross all of them. That's not necessary. Any one wavefront you can take and you can complete the diagram. The next part, calculate the speed of a light in ice. So we have the speed of a light in air and we have the refractive index. So the formula, refractive index is speed of light in air, which is 3 exponent 8 divided by speed of light in medium. That's a formula. 1 mark is for always writing a formula. 1 mark is for the final answer. This is 1.3. This is 3 exponent 8 and v. So we cross multiply. So it will be 3 exponent 8 divided by 1.3. that is 2.3 exponent 8. So this will be 2.3 into 10 power 8, and the unit will be meter per second. The next question, figure 6.1, shows the crest of a wave of water moving from left to the right in a harbor. On a figure, draw three crests to the right of A. So this is a diffraction through the edge. One is a diffraction through the gap. When there's a diffraction through a gap, like you will have the objects, and it will be either a maximum or a minimum diffraction, but this is near the edge only. So we draw the wavefronts near the edge, it will be curved. And it should be equally spaced because the wavelength does not change. That's how. This gap should be equal to this gap because the wavelength is not changing as it does not change the medium. The previous part, you want to take the screenshot of the calculation or the drawing? The drawing, okay. This will be the angle of refraction. State the name of a wave. State the name of the wave process that occur when A passes through A. What we call when A is passing through near the edge or a gap. Diffraction. The next one, figure 6.2, shows the crest of another wave from left to right in a different parts. This wave moved from deep to shallow. On a figure, draw an arrow to show the direction of the movement of a wave after it has passed into a shallow. So as I mentioned, the direction of the wave and the wavefront should always be 90 degree or perpendicular. So take any of them, it's any of the wavefront you can take and draw 90 degree to that wavefront. That will be the direction in which the wave travels. You can draw arrow here, that's fine. You can draw arrow where it meets, that's also fine. But it should be 90 degree to the wavefronts. State the name of a process that occur when the wave passes into a shallow, when it moves from deep to shallow. What we call this? Refraction. When the wave changes the medium, then we call it as a refraction. Complete the table. Complete the table whether it increases, decreases, or stays the same. What happened to the wavelength when it moved from deep to shallow? How you will know it is 90? You have to use how to get a perpendicular, like how to know it's. You have to use a protector for that. Like, for example, if I need a 90 degree, I'll place my protector here and mark 90 and then draw the direction. That's what happened to the wavelength. As you can clearly see, like this gap is wider as compared to in a shallow. So the wavelength is decreasing. If the wavelength is decreasing, speed will also decrease, but the ratio of the speed and frequency, speed and the wavelength does not change, so the frequency will remain unchanged. So it stays same. that will decrease, and this will also decrease. So this was the classified paper for block 3.